Okay, in the last video we solved a problem where we had two ropes attached to the end of a beam, and we called the tensions in those ropes T sub L and T sub R. And we knew the weight of the beam was 100 newtons, and there was a woman standing here, and the force of the woman pushing down on the beam was 490 newtons. And we were able to solve for T sub L and T sub R two different ways. In the first solution, we used the left end of the beam as the axis of rotation. In the second solution, we used the right end of the beam as the axis of rotation. It turns out that we can use anywhere we want as the axis of rotation. Right here, or here, right there, anywhere. In this solution, I'm going to pick right here in the center of the beam as my axis of rotation. If you don't believe me that you can pick anywhere along here, go ahead and try it. After you've seen this video, you should be able to try anywhere along here that you want to be your axis of rotation. As I've mentioned in the last video, when you sum the forces, the axis of rotation is completely unimportant. And before I forget, I'm just going to make note of my positive directions for torque, for the y direction, x direction. And remember, torque is the Greek letter tau, not to be confused with capital T, which stands for tension. Okay? So the summation of forces in the y direction, it's been the same every single time I've done this. Again, this is T for tension, which is a force. It's upward. T sub R is upward. Minus 490 newtons minus 100 newtons equals 0. So that's exactly the same. The difference, you'll see, is in the summation of torque. Since it's an equilibrium problem, alpha is 0, so the right-hand side of this equation is 0. So now we go about summing the torques. T sub L, we look at how far T sub L is from our axis of rotation. 1, 2, 3, 4 meters away. And remember, we could put sine of 90 degrees here because all of these forces are perpendicular to the R values. And so we could put sine of 90 degrees each time, and that's true throughout here. And remember, sine of 90 degrees is 1. We also look at laying our pencil or a ruler right across here, hold it right at the axis of rotation, push in the direction of the force. We see that creates clockwise torque, which is negative. And then we repeat that process for each force, 490 newtons times 3 meters, 1, 2, 3. That's a positive torque. T sub R also creates positive torque. It is 4 meters from the axis of rotation. And then if we want to, we could put in the weight here, 100 newtons. And how far is it from the axis of rotation? 0 meters. You don't have to write that there, but some people like to do that because then you're writing every single force into your torque equation. It just, some of them don't create any torque because they're 0 meters away. Now we look at this equation. We have two unknowns. This equation has the same two unknowns. That means we're going to be able to solve it. So we solve for TL in terms of T sub R. We've done this earlier in the semester, multiple occasions. So we substitute this in, minus 500, sorry about that. Let me start over, minus, and then 590 newtons minus T sub R times 4 meters. Sine of 90 is 1, so I'm going to exclude that now. Plus 1470 Newton meters plus T sub R, and then times 4 meters, and then that's 0. So that's equal to 0. Now we have one equation and one unknown. We can substitute this through. So this is a negative sign, and it distributes through. So negative 590 newtons plus T sub R times 4 meters plus 1470 Newton meters plus T sub R times 4 meters equals 0. And then we say 590 times 4. We get 2,360 Newton meters. Plus TR times 4 meters plus 1470 Newton meters plus TR times 4 meters. And we're running out of room here at the bottom, so we're going to come up here. It's always helpful. Show people your thought process here. So 2360 plus 412, negative 2360 plus 1470. Go ahead and calculate that. That comes out to negative 890. We add 890 to both sides. We also do some simplification on the right side. 4 meters times TR plus 4 meters times TR. That's 8 meters TR. And then, like I said, we're adding 890 Newton meters to both sides. We divide by 8 meters. And we get T sub R equals 111 newtons. We then take that value, we substitute it in up here. TL equals 590 newtons minus 111 newtons. T sub L equals 479 newtons. The exact same answers that we got before. We did a little bit more math. And again, if you want to avoid that math, pick an axis of rotation at the location of one of your unknown forces. And again, if you don't believe me that you can pick any axis of rotation you want, go ahead and try it. Pick anywhere along here. You can pick right there, one right there, one right there, anywhere you want, and do the calculations again, and you'll get these exact same answers.